I said I was gonna try to get him out faster. I'm busy, but I'm trying. Let's do this, guys. Hello and welcome back to creating a horror game from scratch. Last time we just finished up the basics of the animation blueprint, so now we have an idle animation playing, as well as the ability to detect when we're moving and how fast we're moving to change the animation's speed, so that way it actually matches the speed that it's moving. However, in order to add movement to our character, we're gonna have to start combining the pawn with its senses, and its brain, the behavior tree. Fortunately, as for the senses, we don't need to worry too much about them except have them in place. For the most part today, we're going to focus on what a behavior tree is and how to start implementing changes based on logic. If that made no sense, good thing we're about to do it anyway. I'm going to open up my content browser. We're going to go to BPs. We're going to head over to actors. We're going to go into our enemies folder. And within enemies, we're going to open the behavior tree. Now, you're going to start to see, oh, it's on my wrong monitor here. You're going to start to see why I said the behavior tree and the blackboard are very similar. They're two of the same. On the right-hand side, do you notice that it says blackboard up there? So we have behavior tree and blackboard. They're basically yin and yang. What we're going to do is we're going to open up this little behavior tree branch here, and we need to select a blackboard asset. We are going to select the one we created, which for me is BB enemy, and I'm going to go ahead and hit save. Now, I know a lot of this probably looks confusing. Don't panic. This is the behavior tree side. If we click on the blackboard, we'll go to the blackboard side, and you'll notice it's a lot more empty, probably a little less scary. The blackboard, believe it or not, is going to be a set of variables that we update depending on incoming information to choose what to do. But before we get to any complicated choices, let's go back to the behavior tree and do something very simple. This is the root, okay? This is where our behavior tree starts. Unlike real life, however, the root is going to be the top of the tree. Or I guess you could consider this like ground level, and we're going to expand the root down into the ground. In order to get our first command, our first neural connection in our brain, we're going to drag out and let go. Just like we were in Blueprint, we're going to have a couple options based on context. You'll see we can we can select a selector, a sequence, or a simple parallel. A selector basically is going to take in those variables that we have saved and choose one based on the variables. A sequence is going to go from left to right, attempting to do everything. For now, don't worry about simple parallel. Let's keep it simple. We're going to go ahead and just choose a sequence. Now, another node popped up and it just says sequence. However, it's important to name these so you know what's going on. This is how I like to do my naming convention, so I can keep all the information on screen. Basically, what I will do is go to the beginning of this and say, like, this is going to be responsible for walk around. And then I put a space, a dash, and a space and press enter. So now what you're going to see is we quickly know what this branch is trying to do, and we know that it's a sequence. I don't know if there's a naming convention that is used a little bit more than that, but that's what I use and I like it. And then out of the walk around sequence, we're going to pull that again, and this time we're going to do something called a task. You'll notice when we dragged out and let go this time, there's a lot more options. That's because the context is now no longer from the root, but it's from the sequence. So we have some basic tasks that come with the engine. Because like most things in game development, we're going to have to make anything complex or that we want for us. You can see there's things like make noise, move directly toward, move to, play animation, etc., etc. What we're going to do is we are actually going to do move to, and you'll note that right now it says move to self actor. So for learning purposes, let's run through this. We start at the root. We have one option. It's to go to a sequence. the sequence is to move to. And if you go to the bottom, you'll see that we'll move to self actor. Now, what is self actor? How is that being set? Well, on the right hand side, you'll see under blackboard, there's something called a blackboard key, and it's set to self actor. In fact, it's the only thing there. If we go over to the blackboard, you'll note that we have keys, and one of them is self actor. Well, obviously, if we move to ourself, that's just going to succeed rapidly. What I mean by succeed is when you're talking about a behavior tree, anytime you give it a task, the end result is a succeed if it succeeded. And because it can move to itself, it's going to just run this once a frame and be like, we're doing great, so much success. So instead of moving to ourself, what if we instead had it choose a random location near itself and move to that? Almost like an investigation. You know, like if the bad guy's chasing you, he loses line of sight, which we'll get to. And so now we're going to have him walk around, right? He's just kind of aimlessly walking around like he's looking for you. Well, you'll note when we pull out, we don't have an option to do that. So we're going to make a custom task. So what we're going to do, at the top, you'll see we have the option to select new task. And within new task, you'll see that we get a save asset as, and we get the root folder that our tree is in. I'm going to make a new folder though. I don't like them all to just be out and about because sometimes you make 100 tasks. So we're going to open up that tasks folder, and the naming convention's already there for us. We're just going to leave it BT task for behavior tree task. But we are going to erase the blueprint base new. So we're going to make it BT task random location. And it'll open up something that looks a bit familiar. It looks a lot like a normal event graph. I'm going to hit Control-Shift-S to make sure everything is saved, and we'll start making our task. So the behavior tree has to initiate a task, logic has to run, and then the behavior tree has to know whether or not the task succeeded. Because if it didn't succeed, we could technically implement additional things like, oh, if it doesn't succeed, do this. Oh, if it doesn't succeed, throw an error. Don't worry about any of that. The point is, to properly do this, it needs to know if it succeeded, and it has to have an execution start. Like, where does this task begin? So what I'm going to do is I'm going to right click in the event graph, and I'm going to type in event receive. Oh, I got to spell it right. Event receive execute AI. Now you'll see there's two there. Make sure you do the one for AI. And here's the event. This is the node that's going to get called whenever this task gets initiated. Now we're going to code this like it's any other blueprint. We want to find a location near us and then try to move to it. Luckily, AI has some nodes specific to it that will help us along the way here. However, the first thing I think we should do is get our controlled pawn's location. That way, whenever we go to calculate somewhere to go, we'll know if it's near the pawn. So what we're going to do is we're going to pull out of controlled pawn, and I'm going to type in get actor location. And as you can see, that is returning a vector, and you know because it's yellow. Which, if I haven't mentioned in this series yet, a vector is simply, it's three numbers combined. However, in most contexts in Unreal, it's going to be a 3D space, right? X, Y, Z, a vector. So now that we have the actor location, what I'm going to do is pull out of the execution pin, and I'm going to do something that is unique to AI. We are going to get it's get random, and then you'll see location and navigatable radius. Since we're dealing with an AI, and we have, if you remember, this mesh down that's creating the locations that the AI can go, it's going to have that information by default. And what's great is now we can use it to get a random location that we can actually traverse to. So we already know that we want the origin to be where our pawn is located, right? Our pawn, get actor, plug it into the origin. However, then we have this radius. So how far do you want it to be from our current location in order to go there, or in order for that location to be chosen? Sorry, it's night. My meds have worn off. So what we're going to do is we're going to create two variables. The first one I'm going to name minimum, and this is going to be a float. We're going to add a second called maximum. This will also be a float. We're going to make both of these public. And I'm going to right click on the event graph, and I'm going to type in random float in range. So why am I doing this? Well, first let's plug the min and max in. Those go into, pretty obvious, the min and max there. And I'm going to plug that into the radius. So the reason I'm doing this is because I like to design things in a modular way. You'll remember with the door, I wanted to make sure that door could be anything, and it's already programmed, and we can get in there and get working on the door. Same with my tasks, pretty much anything I can. So what I just did is I made a minimum and a maximum that we're going to be able to set every time we use the task. So if we want them to random very low amounts, we can set that. If we need them to random large amounts, we'll be able to set that. So that's what I'm doing. This, however, is where things are going to get weird for those that have never worked with AI. Here's the random location that it's going to return. How do we get that back to the behavior tree from the task? There is a new set of words you need to get locked into your skull if you want to work with AI. Pull out of random location and type in set value. Oh, well, okay. I'm going to change how I'm approaching this. Right click. I know it doesn't make sense. We could just pull out of here and it's easier, but just trust me. Right click. And what I want you to do is I want you to type in set blackboard value as. Okay, these are the words you need to remember, because anytime you're dealing with a blackboard, this is how you go about it. You're not setting a boolean. You're not setting an enum. You're not setting an object. You are setting a blackboard value as. In this case, it's going to be a vector. Now, the reason I didn't just immediately do it from here is because it was only showing this one, and I wanted you to see all the options. So I'm going to plug in the execution pin here. We're going to take that random location and plug it in here, but now you'll see we need a key. What the hell is a key? Look, we can't even compile. Make sure you save, by the way. Well, a key, if we head back to our behavior tree and then the blackboard, is the set of variables that we're creating. So let's create a new key. Remember, it's going to be a vector. And I'm just going to call this target location. You'll start to understand why the naming conventions are the way they are as we continue. So I'm not going to explain too much about why this is target location. So with that created, we can go back to our task. And in order to get this key assigned to target location, we're going to pull out of key and we're going to promote to a variable. Now, what is going on here? Okay, as you'll see, on the left, we have something called a blackboard key, and we can't see it. Let me make it bigger. Selector, okay? And we need this to be open. Anytime you have a blackboard key selector and you need to assign it to something on the tree, it has to be public. We're going to go ahead and click this key, and we're going to press F2, and we're going to name this target location. Now, in this case, target location does not have to be the exact name of the key we just created. In this case, I'm just doing it so that way we know what it's for, okay? So let's make sure we're keeping it clear, guys. Where is our pawn at? We're going to use that as our origin. We need you to pick a random location in a navigatable radius around this origin with a radius of, we're going to do a random number between a min and a max. Spit that number out. Set blackboard value as vector. We pulled out of key. We made it a variable, and it's a blackboard key selector. Compile and save. There's one last thing we need to do in order for this to work. Remember, we need to let it know it succeeded. So we need to pull out of this, and we need to type in finish execute. And as you can see, in case you have branches, you can tell it whether it succeeded or not. In this case, it did succeed. And here is our code to get a random location around us. Let's go back to the blackboard and then head over to the behavior tree. And what we're going to do is now when we pull out, we'll be able to see our task that we created in here. You'll see BT task random location. I'm going to click on it. We'll pull this over and you'll see when I click on the task on the right hand side, you'll see now we can set the minimum and maximum. So we'll say a minimum of 300 and a maximum of like 750. Those are two random numbers I pulled out of my ass dealing with the house we're dealing with. And then you'll see target location. This is the name I gave it, but you'll see we have a drop down menu here and it's currently set to self actor. But if we open it up, you'll see we can set it to target location. So now, and it tells you on the task, luckily, it shows you random location, minimum of 300, maximum of 750, and we're setting target location to target location. So now, whenever it runs through this tree, I guess I should specify root, walk around, and it's going to do a sequence again from left to right. So it's going to get a random location within that. It's going to set it to target location, and then it's going to move to, and as you can see, it's currently moving to self actor. So we're going to go to the right hand side here, change that to target location. Now, behavior trees are kind of nice. This move to knows when it arrives at its location. So we don't have to set up any extra logic here. We don't need to say, whoa, hold off, let it get to where it's going before you choose another location. We don't have to do any of that. Luckily, these tasks, specifically the one built in for move to, it's smart enough. It's like, this is my task. I got to get there first before I run the code again. Okay, great. So we have a really, really, really basic behavior tree. I'm going to make sure it's saved. But how do we get that to our pawn? How does this pawn even have any idea about that behavior tree? Well, on BPC enemy, make sure you've got the whole thing selected, not like the mesh or the arrow. You want the actual BPC. Go to the right hand side and under details, type in AI space and then like CON. And you'll see that down here at the bottom for pawn, it says AI controller class. And right now it's set to AI controller. We're going to set this to AIC enemy because that's the AI controller we made for this specific enemy. And we're going to hit compile and save. However, there is one last thing we need to do. Go ahead and delete the CON and just leave the AI, because what we also need is above the AI controller class. We need auto possess AI. It's on placed in world, but we need this to be on placed in world or spawned. Compile and save. You know, I'll be honest, I don't know the difference, but I know it never works unless I do it that way. And I just want to be upfront with you. I'm not going to be like the other YouTubers and just breeze over the fact. I don't know why it has to be set like that. Which means if you do, and you're confident that you do, leave a comment and let us know. Okay, great. But the AI controller and the behavior tree are two separate things. I've been very clear about that. So, cool. The AIC is going to immediately possess this thing, but that's not going to run the behavior tree. Well, let's open up the AIC. If it does this, by the way, it's on crack. Just hit open full blueprint. Don't know why it does that. If you do, leave a comment, because if you could tell me and it doesn't do it anymore, I'd be so happy. Anyway, we're going to hit Control-Shift-S, make sure it's all saved. And on the event begin play, I hope you're ready for this. We're going to pull out and we're going to type in run behavior tree. There it is, boys. We're going to, or girls, and we're going to grab it all. We're going to press Q, make sure it's all nice and straight. And then we have the BT asset. We're going to open that up and check it out. There it is. Compile and save. So let's go ahead and make sure we know exactly what's happening here. We have a pawn that is going to get possessed by the AI controller, because this is its senses. The senses are going to run the behavior tree. So it takes over the pawn and then it says, run this behavior tree. The behavior tree, which is the brain, it makes decisions, goes, out of the root, it says, oh, I have a walk around sequence. I need to get a random task within this range, and then I need to move to that location. And every time it succeeds, it's going to restart and do it again. Very simple setup, but you can see why I'm going slow. Let's go to the level house map. Hit Control-Shift-S, Control-Space, and we're going to drag our BPC onto our map. We're going to go ahead and just put him down there. Now, whenever I hit play, just so you know, he isn't going to be able to see us. He isn't going to chase us. His brain is like a fly. It says, go around randomly. And that's all that's going to happen. We're on cinematic scalability. Let's not do that. Let's drop this down to epic. Why was that? Anyway, I'm going to go ahead and hit play. And check it out, dude. There's your AI. Oh, he's coming. By the way, I love that we have the flashlight still because it makes it seem spooky even though it's not. It's like, oh God, the zombie, he's coming. Now, right now, as you can see, he's very fast, very jolty. And one thing that I really want to show you in this video is we're also going to make it so he doesn't snap. You see how he's snapping when he turns left and right? We're going to go ahead and fix that. So I'm going to press escape. And what I'm going to do is go up to the BPC enemy. The reason he is so snappy is because in character movement, we need to change a couple things. The first thing we need to do, we're going to type in rotation. So right here, you'll see we have use controller desired rotation. We have orient rotation to movement. If you use desired controller desired rotation, what it's going to do is the controller, being the AIC, which is running the behavior tree, is it's going to say no matter what, you need to be going the direction the controller wants you to go, okay? So we don't want that. That's basically what it's doing right now, and there's a reason for that. What we want is we want to orient the rotation to movement. So if we turn this on, what this is going to do is allow us to set a speed that thing is allowed to turn. If you look right now on Z, which is the yaw, which is like around the vertical axis, it's set to 360. Well, let's hover the rotation rate. It says change in rotation per second. So right now, this thing can move 360 degrees in a second. That's too many. So to make this look a little better, I'm going to drop this pretty drastic and then slowly move it up. Let's move this to 90. So it would take 4 seconds for this thing to turn around completely. Probably a bit slow, but let's go ahead and take a look at that and see what it looks like. I'm going to hit compile and save. And one last thing, because I want it to be easy to actually see this thing, because as you saw, it was sprinting around like crazy, I'm going to change the max walk speed. Right now it's set to 600. Let's set this to like 200. No, not 2. Wait, what? Hold on. Why did that switch? It switched to MS. Why did it switch to MS? I actually don't know. I didn't do anything. Why did it do that? Whatever. 2, because 2 is, I believe, 200 centimeters. So for me, 2 were... Oh, and then it switched back to 200. If you're ever using Unreal or game development, it seems like nothing makes sense. It's probably because it doesn't. This stuff goes crazy, I swear. Anyway, we've slowed him down and we're making him turn now. Let's hit Control-Shift-S, make sure it's all saved. Let's go ahead and hit play, go back into our level, and now he's moving a lot slower. You'll see the animation slower because of it. And right now, he's still snapping, actually. Why are you snapping? Ah, there it is. Okay, I forgot. If you click on the BPC enemy and you go to your details and type in rotation, you'll see that it also has a different set of rules. And what we're going to do is we are going to make sure, again, orient rotation and movement is checked. But see where it says use controller rotation, y'all? That's essentially the same thing I said earlier, where it was saying you need to snap to the direction of the controller. So we're going to uncheck it. So now it should be able to glide between directions instead of booking it. And to help us see it as well, and it'll just look nicer, let's head back to the behavior tree. And after the move to, we're going to pull out and we're just going to do wait because that already exists. So now what it's going to do is get the point, move to it, and wait for a moment. It's set to 5 seconds. Let's just set it to like 2. By the way, fun fact, you can do a random deviation. So if I put a 1 here, now it can be 1, 2, or 3 seconds, or I believe any of the decimals between. I don't want that. We'll just leave it on 2. I'm going to hit save, and now we should be able to watch this guy walk around. There we go. Look, he's not... Oh, I didn't mean to do that. Oh, God. Oh, yeah, look, he's just walking around. Go somewhere else. Yep, see, he's trying to turn. Did you see that? Oh, there he goes. Now, he's turning very slow, but I set it like that on purpose. You wouldn't want him to actually turn this slow. Also, his sprint animation does not play nice with a slow anim. I would definitely change this walking anim to something else if I was going to use this guy, but... Okay, cool. So now we've got a guy that walks around randomly. Let's go ahead and make it so he spins a little faster. We're going to go over to this. Remember, by the way, I don't think... What's crazy about this and why I get confused half the time when I'm doing this, I don't believe this rotation rate is actually the one that he's using, even though we had to remove the controller yaw. I believe it's still character movement, where it also exists. I'm just as confused as you are. And we're going to take the rotation rate, which is also set to 90. Did I set it to 90? I think I did. And let's set this like to 180. I think 180 will be a lot better. Let's see what he looks like with 180. If it doesn't increase, we know that that's the wrong one, though. Oh. Okay, let's see if he turns faster now. I can't tell. It looks like he is. It looks like he's turning a lot faster. Is he not? No, it's definitely trying to do the animation. It's just so slow, it doesn't know what to do with it. Because you can see him try to pick his leg up. Okay, good. But yeah, he's turning faster now. Adjust it to how you like it. But yeah, so now we have a very basic set of random movement for our monster. Something I want to show you, by the way, if I hit play and Alt-Tab out, so if we go in, I Alt-Tab out and go to the behavior tree, you can actually see what your behavior tree is doing. This is excellent for debugging. In fact, when I'm trying to debug AI or I'm working with it in general, you'll remember earlier in the video, if I left it in, it opened on the wrong window or the wrong screen, because I will take it and I'll put it on the side screen. So when I'm doing my tests, I can watch the behavior tree and see what decisions it's making. I'm pumping these out a little faster, so I'm going to end this one here. These are confusing topics if you've never done them. I hope I'm making them as simple as possible and you're getting a little bit of a grasp of what's going on. I encourage questions and I encourage comments, especially if they help answer the things that I don't know. Remember to like, comment, and subscribe, and I'll see you in the next video.